We're now ready to dive into the control rig editor and rig our eyes to the skeletal mesh. Let's go! Let's start by right-clicking in the content browser, go under Animation, Control Rig, and creating the star node control rig asset. Let's open it up. By clicking on Import Hierarchy, we can import our skeletal mesh asset. The first thing we need to take care of is the discrepancy between the curve values in the control rig and the ones of our face material instance. Since we changed some values to set the face texture to our liking, we need to apply them inside the control rig too. Let's organize our working window to fit all the panels we need: the material instance, the curve container of the control rig, and the variables panels. Let's then create a new variable by clicking on the plus icon and call it ORG left eye X offset, where ORG stands for organization. Then change the variable type to float. In the material editor, let's toggle the variable on just to copy its value, then toggle it off again. For our control rig variable to be editable, we need to first compile the rig. We can then paste our material instance value into the variable default value parameter. We can now repeat this process for all the curves we've got available in our control rig. Once done, we can close the material instance panel and dock the curve container back to where it was. We have created and set the values for each variable, but the face doesn't look right yet. Why? Well, that's because the curves of the control rig stayed untouched. We need to change them in the forward solve. To do that, we want to drag and get each float variable into our control rig graph. Then drag out of the variable node output and connect it to a set curve value node. We then want to set the curve value to the specific one the float variable is addressing, in this case, the left eye X offset. We can then plug it to the execution pin of the forward solve and repeat the same process for each float variable we have created. Once done, we can compile and save, not to lose all of this repetitive process. And then we can comment the nodes we just created to keep our graph clean. We can now move on to creating the global and head control shapes of our rig. In the rig hierarchy panel, let's right-click on the head controller, go under New, Add Control for Selected. Then duplicate the controller we just created and drag and drop the duplicate on the first head control to make it its child in hierarchy. Let's rename the first controller Global Controller and the second one Head Controller. Since our skeletal mesh is small, let's select both of our controllers and scale them down in the Shape Details panel. To make our life easier, let's hide in the Shape Details the Head Controller until we're done customizing the Global Controller. We want the Global Controller to be of a thick hexagonal shape and fully yellow. We can then rotate the shape 90 degrees in Y to make it parallel to the floor. Let's switch back to the head, make it visible, and then arrow for thick shape. When we made the controller a child of the global, it inherited its local transform into the offset. Let's reset those values in the transform details of the head controllers to make it snap back to the world origin. We can then scale down the shape of the controller, make it orange, and rotate it 90 degrees in the Y-axis. Let's now select it in the viewport and drag it up above the head to make it easily selectable. Once done positioning the controller, remember to right-click on it and set Shape Offset from Current, elsewise it will lose this translation upon recompiling. Let's go back to our graph and add a sequence node after the forward solve to execute more operations. Then drag and get the head controller into the graph, and drag and set the head joint into the graph. Then plug the second execution pin output from the sequence node and plug it into the bone transform execution input. Let's add a reroute node to keep our graph clean. We can then plug the transform output of the controller into the transform input of the bone and execute the node. We don't need to set the global controller since it's a parent of the head controller, and it will move the head controller through the chain. We're now ready to create some FK controllers for our pupils. Let's right-click on the head controller and create a new control. Then place it under the head controller and name it IL controller. In the shape details, let's color it blue and make it a thick sphere. We can then lock the scale of the shape and resize the control to about the eye size. Let's switch to right view in our viewport to view the front side of the face and place the eye controller on the left eye. Let's do the same thing from the side. Once positioned, let's remember to right-click on the controller and set offset transform from current, not to lose the translation we just applied to the controller. We can now repeat the same process for the right eye, coloring it red and shift right-clicking on the offset and shape transforms of the left eye to copy them, then shift left-clicking on the right eye transforms to paste the values. To create the effect of our pupils moving around when rotating the FK controllers, we want to map the controller rotation to the X and Y translation of our pupil texture. To do that, let's add a sequence after the setting of the head joint, then drag and get the left eye controller. We want to isolate the X and Z rotation of our controller, but we can't access them directly from the transform node. In order to expose the rotation axis, let's drag out of the rotation blue pin and add a cast node to convert it to a rotator. Let's then split the rotator into the 3 different coordinates by adding a break node. We can now access the roll, pitch, and yaw of the rotator, X, Y, and Z axis respectively. Before moving forward, we want to make sure the values we're getting from the rotation of the controller are local and not inherited from its parents in the hierarchy. That's because we want the controller to start rotating from a local value of 0 rather than an offset global value, and avoid offsetting the 2D texture mistakenly. To do that, let's switch the space of the get transform node into a local space. We now drag out of the roll float pin and add a set value node. Let's connect it to the first execution pin of our sequence node and set the curve to the left pupil X offset. If we disconnect and reconnect the execution pin, we notice a slight offset in the pupil position. That's because we're setting the curve to a value of 0, thus bypassing the variable we had applied earlier in the video. To prevent this offset from happening, let's add the float of the left pupil variable to the roll value of the left eye controller. Then plug the result into the set curve node. When we rotate the left eye controller, the pupil is now moving way too fast. We can reduce the influence of the controller over the curve value by multiplying the roll to a very low value. Let's also make the value negative to match the axis orientation of our controller. We're now missing the mapping of the yaw rotation or Z rotation of the controller. Let's copy all of these nodes and paste them underneath them. We're using the same controller, but this time we want to plug the yaw float output into the multiply and switch the variable added after the multiply node to the left pupil Y offset. We can then drag out an execution pin from the set curve value, switch it to the left pupil Y offset, and connect our add node output to it. Before moving on to the eye aim, we want to add 2 small highlight controllers to move our eye highlight around. Let's duplicate the left eye controller and rename it Highlight Left Controller. We can then shift right-click to copy the offset transforms of the left eye and shift left-click to paste them into the offset of the highlight controller. We can do the same thing for the shape transform too. We can then change the shape of the highlight to a thick circle and color it light blue. Let's resize the shape a bit and rotate it on the x-axis to make it parallel to the pupil. Then position it in the viewport to be on top of the 2D highlight texture. Finally, let's remember to right-click on the highlight controller and set offset transform from current. Since the circle is so small, we can make the shape a little thicker to make it more readable. Let's drag and get our highlight controller into the graph, and this time, we want to move the circle around and map the Z and X axis to the highlight texture to move it around. Let's open the transform pin, then the translation one. To move the pupil horizontally, we want to drag out of the Z axis and multiply the float to adjust the controller influence over the texture offset. We can then add that to the highlight X offset variable like we did with the pupil controller, remember? Lastly, let's set the curve value to the output pin of the add node and switch the curve to the left highlight X offset. We can then get the execution pin from the set curve value of the left eye Y offset node and add a reroute node to keep the graph clean. That's important. But the highlight has now disappeared. Why? That's because we forgot to switch the space of the controller transform to local. Therefore, it was inheriting the translation from its parents in the chain and wasn't resulting to a clean 0. When moving the highlight controller around, we notice its influence is inverted and way too slow. Let's adjust the multiply node to a negative and higher value. Let's then duplicate these nodes down below and map the x-axis to the left highlight y offset. Remember to switch the variable in the add node too. Both pupils and highlights are now rigged. Let's move on to the IAM. Let's create a new control in the rig hierarchy and make it a child of the head controller. Let's rename it IKI's aim controller. Color the shape yellow and make it a thick square. We can now scale the shape down and rotate it to make it face the front view. Let's scale it as a rectangle encompassing both eyes and drag it up to the eye height. Then position it a little bit further than the eyes in the side view. Once done, remember to set the offset transform from current. Let's now create a new controller and make it a child of the eye's aim. Then name it IAim left controller. Color it blue and copy-paste the offset and shape transform from the eye's aim controller to the left eye aim controller. Then change the shape to a thick circle, like the highlight one. Let's reset the offset transforms to snap the controller right in the middle of the eye's aim rectangle, then adjust a bit the scale. We can now duplicate the left IAM controller, rename the duplicate IAM right controller, make it red, and copy-paste the offset and shape transform from the left IAM onto the right one. Let's then move the left and right IAM in front of their respective eyes in front view. Then set offset transform from current once done. We now have our IAM controllers ready for setup. Let's switch to our whiteboard. Okay, so far we got the FK eyes together with an IAM. We want the eyes to be able to rotate and the IAM to translate. The FK eyes should always follow the IAM, but we want to be able to rotate them around. Thing is, if we parent the FK eyes to the IAM, we are not able to offset them anymore. They'll be linked to the IAM translation. So, we need an intermediary between the two, being a null taking over the aim constraint so that the FKIs will be available to be rotated and be used as offset on top of the IAM. What we will end up having will be the FKIs, a null on top of them, and the IAM. So the IAM will come first in chain, followed by the null, and then the FKIs controller. Let's apply what we just learned by right-clicking on the left eye controller and adding a null above selected. Same for the right eye. Then rename the nulls to FKIL null and FKIR null. In the graph, let's drag down one more execution pin from the sequence, then plug it to an aim constraint. We want the child of the aim to be the null. The rest of the settings can stay unvaried, but the parent of the aim should be the IAM left controller. We can now move the IAM around and the IAM controller will follow, but not the pupil. Why is that? Because the IAM controllers are operating in local space. Therefore, we need to add the rotation of the FKI null manually in our graph. Let's make some space and drag the FKI left null into the grid. Then recreate the same setup as the I left controller by casting and breaking the rotation pin to get the roll float value. We can then add the roll of the left eye controller and the one of the null together and plug that to the A input of the multiply. Remember to switch the null space to local too. Let's make some more space in the graph and copy-paste the null setup from the left eye X offset below the Y offset. Then switch it to the yaw or Z rotation value, and add it and plug the result to the multiply node. We now have the left eye aim working and can do the right one on our own. And how about implementing the Sprite animation to the rig too? To do that, let's select both the left and right eye controllers. Then duplicate them both. Select the duplicates and add them as a child of the head controller. Let's rename them IL Animation Controller and IR Animation Controller respectively. Select them both and change their shapes to solid spheres. Since the animation of the sprites works on whole numbers, let's switch the value type in the control details of both controllers to integer. Make sure Draw Limits is turned on. Our sprite sheet has 3 elements, starting from 0, 1, and 2. Therefore, we can set the max limit of our integer to a value of 2. We can see the limits of our integer being long compared to the side of the head. Let's fix that. We can scale down the solid spheres in the shape transform, but the limits are still long. To fix that, we need to set a lower offset scale in the transform details of the controllers. Let's focus on the left eye animation controller for now. We need to move it manually using the offset transform values rather than from the viewport, since it's an integer working only in the x-axis. Let's position it as wanted. Since the eye sprites are basically closing as we increase our integers, we want the limit line to go downward rather than upwards. To flip that around, we can use the offset transform of the controller again. Awesome! Our Let's controller is ready. Let's jump into our graph. Drag and get the left eye animation controller into the grid, then add a set curve value node. Set it to left eye animation and plug the integer value pin into the float input of the curve value. An integer to float node will be automatically added. We can then drag the execution pin from the aim constraint onto the set curve value and ta-da! Our eye is now animated. Let's apply the same process to the right eye on our own. As of now, our eye aim is always following the head controller rotation. There is no way of going around it. But what if we wanted it to follow the global controller only? Let's switch back to the whiteboard. What we have so far is a global controller and a head controller. Then we have the eye aim following the head controller. And we want to find a way to have the eye aim be controlled by the global controller. Let's get an overview of the current hierarchy. We have the global controller, followed by the head. And underneath the head, we've got our eye aim controller. What we want is to create a space between the head and the eye aim, and another one underneath the global controller, outside our hierarchy. In our switch, we will be parenting the eye aim underneath either one space or the other. Let's apply what we just learned from the whiteboard. Let's add a null above the eye's aim functioning as space switcher for our controllers, then name it IK eyes aim null. We now need a space switcher for our world space. Let's then create a new null under the global controller and call it IK eyes aim world null. And rename the former IK eyes aim null to IK eyes aim local null for clarity. Awesome. We now need the switch parameter to let the animator select the option they'd like. To do that, let's right-click on the IK eyes aim controller and create a new animation channel. Let's change its value type to Boolean and call it IK eyes aim local world switch. We now have the switch available upon selecting the IK eyes aim controller. By default, it's set to false or toggled off, therefore set to local space as it is now. We want to make sure the world null matches the same position as the eye aim local null when applying the control rig to our character in Sequencer. To do that, let's set the construction event node, then drag and set the world null transform setting it to initial, then drag and get the local null transform setting it to initial too. We can then connect the two transform values and plug them to the construction event execution pin. Let's navigate to our forward solver again, right after setting the animation curve values for the eye, and connect the branch to the execution pin. Let's drag and get our local world switch boolean into the graph, then connect its output to the condition pin of the branch. We want to apply changes to our nulls only if the condition is set to true. If it's set to false, nothing should change. Let's drag and set transform of the local null, then drag and get transform of the world null. Then connect the two transform and plug the true execution pin to set the transform node. Whenever we set the boolean to true, the IAM stops following the head and just follows the global controller. Perfect. Congratulations, we now have our 2D face fully procedurally textured and our control rig ready to be tinkered with in Sequencer. Well done! The next video will just be a sped up demo of me animating the rig in Sequencer. You don't have to follow that along, but you can watch it if you're curious. Thanks for sticking around for the whole course, and I hope you'll find this useful and will be able to apply these principles to your future animation projects. If anything was unclear or you're left with some questions, feel free to drop them in the comments down below. Thanks again. Bye.